Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 6 on complex analysis. Today I'm going to teach you very important concepts of complex analysis. First, let me tell you what are the topics that I'll be covering today. The first topic that I will teach you is basic representation of function of a complex variable. Next, limit of a function of a complex variable. The third topic will be under what condition a function is said to be continuous at any point. Next topic will be how to find the derivative of a function of a complex variable. Then I will define what is analytic function. After defining what is analytic function, I will tell you how to check the analytic behavior of a function by using Cauchy Riemann equations. And finally, I will solve two numerical problems. So without wasting time, let's get started. First topic, function of a complex variable. Students, the basic representation of function of a complex variable is f of z equal to u plus iota v. So f of z is equal to u x comma y plus iota v x comma y. Here u is called as the real part of the function of the complex variable z, and v is known as the imaginary part of the function of the complex variable z. Now let us give you two examples. First one is f of z is equal to z square. We know that in Cartesian form z is represented as x plus iota y. So x plus iota y whole square. Now let us apply a plus b whole square formula. So if we apply a plus b whole square formula, then we will get x square minus y square plus iota into twice xy. So we have seen that the real part of f of z will be equal to x square minus y square, and imaginary part of f of z will be twice xy. So this one will be u in our case, and this one will be v in our case. Next example is f of z equal to z into z bar. So we know that z equal to x plus iota y, and complex conjugate of z will be equal to x minus iota y. Now apply a plus b into a minus b formula. If we apply, we will get a square minus b square, x square plus y square. So we have seen that for this function, the real part is x square plus y square and imaginary part is 0. So this is the real part, and imaginary part will be equal to 0. Okay? Now the next topic is limit of a function of a complex variable. Students, suppose we have a relation like this: limit z tends to z naught f of z equal to L. Here L is any number. Then this number L is known as the limiting value of the function f of z when z approaches z naught. Here one important point is that this limit will exist only if this limiting value is independent of the path along which z approaches z naught. Next topic is continuity. A function f of z is said to be continuous at z equal to z naught if this limit exists and the limiting value of f of z when z approaches z naught is equal to f of z naught. Now the next topic is derivatives. The derivative of a function f of z is denoted by f prime z, and it is defined by f prime z is equal to limit delta z tends to 0 f of z plus delta z minus f of z divided by delta z, provided this limit exists and the limiting value is independent of the path along which delta z tends to 0. So in such a case, we say that this function f of z is differentiable at z. Okay? Next, I am going to define what is analytic function. Students, a function f of z is said to be analytic at the point z equal to z0 if this function f of z satisfies two conditions. First condition is that this function f of z has to be differentiable at the point z equal to z0. Apart from that, this function f of z has to be continuous at the point z equal to z0. Here, I want to mention very important point. This is just a definition of analytic function. Please do not use this definition to check the analytic behavior of a function. Always use CR equations to check the analytic behavior of a function. So, this is my recommendation to all of you is that please do not use this definition to check the analytic behavior of a function. Next, I am going to teach you one very important theorem. And according to this theorem, the necessary and sufficient conditions for a function f of z is said to be analytic at all points in a region capital R are: number 1, this function f of z has to satisfy CR equations or Cauchy Riemann equations. And these Cauchy Riemann equations are del u by del x is equal to del v by del y, and del u by del y equal to minus del v by del x. So these are known as the Cauchy Riemann equations in Cartesian form. So these are known as the CR equations in Cartesian form. And this condition 1 is known as the necessary condition for the function f of z will be analytic at all points in the region capital R. Next condition is that all the partial derivatives, that is del u by del x, del u by del y, del v by del x and del v by del y, should be continuous functions of x and y in that region capital R, and this is known as the sufficient condition. So this one is known as the necessary conditions, for a function f of z to be analytic at all points in a region capital R, and this is known as the sufficient conditions. ठीक है.